Okay, this thing here is called the base, and that's the index. Base index. So what does that mean? That means 2 times 2 times 2. That means 2 times 2 times 2. Why is there 3 of those? Because there's a little 3 there. 2 times 2 is 4, 4 times 2 is 8. Here's another one. Let's try 2 to the power of 4. That means, how many 2's are there going to be? There's going to be 4 of those. 1, 2, 3, 4. Because there's a little 4 there. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And you can have other combinations like this. 5 to the power of 3. That means 5 times 5 times 5. 5 times 5, 25. 25 times 5, 125. Remember, that's called the base and that's called index. Right, if I wanted to simplify this, you look at this and think, hang on, there's a base of 2, there's a base of 2. The bases are the same. So when the bases are the same and you're timesing, what do you do with the indices? You add them. So copy the base, and then add the indices. 3 add 5 is 8. Here's another one. Right, the base are the same. 5, 5, 5. So copy the 5. So if you're timesing, you have to add the indices. 7 add 2 is 9, 9 add 4, 13. But what about when you're dividing? Let's say you're doing this. Right, the base is the same, copy the base. But because you're dividing, you have to take away the indices. 7 take away 2 is 5. Right, this is slightly more complicated. Right, deal with the numerator first, the top bit first. The base is the same, so copy the base. And because you're timesing here, you have to add the indices. 7 add 2 is 9. And don't forget at the bottom, you've got this thing here. Now that becomes division. That fraction is a division. And as I've said to you here, if you're dividing, you have to subtract, take away the indices. So that will be 9 take away 2, 7. And you can do the same thing with letters as well. I mean, it doesn't have to be numbers. So for example, if you got something like that, the base is the same and you're timesing. So what happens when you times? You have to add the indices. So 7 add 2 is 9. If you see something like this, you can put a 1 there. It's the same thing. So the base is the same, and because you're timesing, you have to add the indices. 1 add 5 is 6. Now you might come across something like this. Okay, so what does that mean? It's x to the power of 3 times x to the power of 3. Why twice? Because there's a little 2 there. So if that was, for example, 4, you'd have to have it a few more times there. 1, 2, 3, 4. Why is there 4 of those there? 1, 2, 3, 4. Because of the little 4. So what do you do then? The base is the same, and you're timesing. So what do you do with the indices when you're timesing? You have to add those. 3 add 3 add 3 add 3 is 12. So it's x to the power of 12. Quicker way of doing it is like this. When you've got something like this, just times the little numbers together. 3 times 4 is 12, so it's x to the power of 12. Look, same answer. What about this one here? There. Copy the base, and then 3 times 2, 6. Now I will show you a substitution. I'm making some letters up. Let's say A is worth 2, B is worth 3, C is worth -5. I've made these letters up and these numbers up. Right, let's work out what, for example, 4 plus a is, I'll replace the a with 2. 4 plus 2 is 6. Let's try another one. Let's try 5b. Whenever you got a number and a letter together, or a letter and letter together, and join like that, there's an invisible times sign. Replace the b with 3. Remember, b is worth 3. So that's 5 times 3, 15. Let's try something a bit more complicated. There. Replace the a. Remember, there's an invisible times sign. A is worth 2, and the b is worth 3. 2 times 2 is 4. 4 plus 3 is 7. Let's try with the negative. There's a time symbol there. Let's try, that one. 8 times c. C is worth -5, so that's 8 times -5. Whenever you multiply a positive with a negative or a negative with a positive, negative always wins out. So answer will be negative something. 8 times 5, 40. If you got, same with division as well. So whenever you're timesing or dividing, you think about who wins. Let's try this one. Replace the c with -5. Whenever you multiply two negatives together, two negatives make a positive. So 3 times 5 is positive 15. Now I'll show you how to expand brackets. So you've got something like that. Remember, there's an invisible times sign there, so you do 2 times x is 2x. 2 times 4 is 8. I've expanded the bracket. Let's try another one. Four times x is 4x. 4 times 7, 28. Don't forget that. So when you expand the brackets, you get this. When you expand the brackets, you get this. But what if I started off with this instead? And I was told to factorize it. Here, remember, I've expanded this to get this. I've expanded this to get this. But what if I want to go backwards? Say I'm given this, 2x plus 8. Factorizing will take me back to this. Factorizing this will take me back to that. Factorizing this will take me back to that. So let's factorize this. So you start off with brackets. Factorizing means putting brackets in. Right, the biggest number that goes into 2 and 8. What's the biggest number that goes into 2 and 8? Is obviously 2. Check. Is the 2 in the 2 times table? Yes. Is 8 also in the 2 times table? Yes. So what you then do is 2 times something. 2 times something give me 2x. It's x. Check. 2 times x is 2x. 2 times something to give me 8. It's 4. So when you factorize that, you get this. See? When you factorize this, you go back to what you had originally. There. So when I factorize this, I've gone back to what I had originally. Right, let's try something totally different. Let's factorize this one. So when you want to factorize this, start with brackets and think, what's the biggest number that goes into 16 and 20? It's 4. Check. Is 16 in the 4 times table? Yes. Is 20 in the 4 times table? Yes. Now, 4 times something to be 16x. Well, 4 times something to be 16. It's 4. 4 times 4 is 16. Don't forget the x. 4 times 4x is 16x. And then 4 times something to be 20 is 5. There you go. This thing here has been factorized. And then you can check by expanding the brackets. 4 times 4x is 16x. 4 times 5 is 20. Right, now I'm going to show you how to simplify expressions. Right, here's an example of an expression. An expression doesn't have an equal symbol, right? That's an expression. It hasn't got an equal symbol. It's just full of numbers and letters. Yeah, I'll throw something else as well. I'm just making this up. There. So if you look at this expression, remember an expression doesn't have an equal symbol. Collect like terms. You got X family, look, X and X family. Any other X's? No. So 2X add 3X makes 5X. Now look at the Y family. That's 8Y take away 5Y is 3Y. And now just the number family, just the number. 8 add 3 makes 11. Done. That's been simplified. You could have things like this as well. Right, we've got two different families here. We've got the X squared family and we've got the X family. They almost sound the same, but there's a slight difference. So 2x squared add 5x squared is 7x squared. 3x minus 1x, that is a 1 there. You can imagine there's a 1 there. Now you've got the X family. 3x minus 1x is 2x. Simplified. That's been simplified now. Now I'm going to show you how to solve equations. Equations are equal symbols. So basically this is saying it's something times 2 add 3 to give me 11. Something times 2 add 3, that makes 11. So I need to work out what that something is. So I can use a function machine to do this. Look, something. What am I doing to the something? To the x? I'm timesing by 2. Then what am I doing? Adding 3. And what's the output? Is 11. So something times 2 add 3 to give me 11. Now I need to go backwards, inverse operation. Opposite of add is take away. So take away 3. Opposite of times is divide. So divide by 2. Let's see what we get now. 11 take away 3 is 8. 8 divided by 2 is 4. The answer is 4. Let's try another one. Something times 2 take away 3 to give me 7. Something times 2 take away 3 and the output is 7. So go backwards, inverse operation. Opposite of take away is add. Opposite of times is divide. 7 add 3 is 10. 10 divided by 2 is 5. Right. 4 keywords here: expression, equation, formula, identity. What's an expression? An expression doesn't have an equal symbol. So we've seen this already. Expression, we've just seen this just a while ago. It's got no equal symbol. Okay, that's an expression, that's an expression, that's an expression, that's an expression, that's an expression. I'm just making this up. That's an expression. 5 apples plus 2 apples. That's an expression. It's got no equal symbol. But I'm going to explain to you now what an identity is. See this thing over here, which we looked at? I know that's an expression, but did not say this expression here is the same as this expression. When we grouped into families, remember 2x plus 3x is 5x, 8y take away 5y is 3y, and 8 plus 3 is 11. Right? That there is identical to this, and the symbol for that is this. It's not an equal symbol, it's an identical symbol. So this one here, 5 apples plus 2 apples, that belong to the same family. 5 apples plus 2 apples is identical to 7 apples. So that's the identity symbol, right? We should not really do this. Yes, I know 5 apples plus 2 apples is equal to 7 apples, but really you should say it's 5 apples plus 2 apples is identical to 7 apples. So here's an expression, these two expressions are identical. Just in the same way, when we expanded brackets just a while ago, here, remember when I expanded this, 2 times x is 2x, 2 times 4 is 8. This expression and this expression are identical. So what you'd say is, once you've expanded this, it's identical to 2 times x is 2x, 2 times 4 is 8. Alright, identical expressions. So by itself, it's an expression, by itself is an expression, but then they're identical. These are called, when you're solving, when it's got an equal symbol, like this, when you're trying to find the missing letter, like we did, something times 2 plus 3 to give me 11. Remember we worked this out just a while ago? When you're trying to solve this, i.e. trying to find the missing letter, it's called an equation. Alright, it's got an equal symbol. It's an equation. So expression, example, 2 apples plus 5 apples. Identity, 2 apples plus 5 apples is identical to 7 apples. An equation, something times 2 plus 3 to give me 11. That's an example. And the last one is a formula. A formula does something useful. Like for example, when you've got a rectangle and this is the length and that's the width, and you want to work out the area, for example, area is equal to length times width. And that is something useful. For example, for a triangle, base and height. To work out the area of the triangle, it's base times height, and then you halve it. That gives you the area of a triangle, right? So formulas also have equal symbol, just like equations. But here, you're trying to find the missing letter, something times 2 at 3 to the 11. That's something, that's what you're trying to find out. That makes it an equation. Whereas a formula does something useful.